So, great. Well, I'm going to hand over to you, Zach, and yeah, take it away.
Sounds good. Thanks for the intro. Yeah, hey everyone. My name is Zak Ayesh. If you don't already know me, I'm a developer advocate with the FVM team. Matt is my colleague. And today I'm going to be talking about data DAOs on the FEVM, or the Filecoin Ethereum Virtual Machine. Let's go ahead and move on. So, quick story. You might have already heard this if you've seen some of my previous talks. But one of my first projects getting into Solidity and the smart contracting space was making a dynamic NFT with a picture of my cat. So this is my cat, Coda. He looks like a demon in this picture, but I swear he's a very sweet kitty. Um, but essentially, the NFT was a dynamic NFT play on Schrodinger's cat, right? So if you're a nerd like I am and familiar with physics and science jokes, Schrodinger's cat is a cat that you open the box and it's either alive or dead, um, with a 50-50 chance. Of course, I would never want my cat to be dead. So instead, there's a 50-50 chance you would mint this box. And after you mint it, it could either become a attack cat, which is the cat that you see here, or a sleeping cat. And today I'm going to actually use this same photo of the attack cat to make a deal proposal on the Filecoin network. And we're going to make that deal proposal via a DAO, right? Instead of just making the deal proposal normally, we're going to make the deal proposal by going through some DAO contracts first. And by deal proposal, I mean storage deal, right? So the Filecoin network is made to store deals. We'll talk about that in a bit. Right, so I'm going to give a little bit of introduction on deal making on Filecoin, give a little bit of introduction on DAOs, and then we're going to go on a quick demo. I have about 30 minutes today, so the demo is going to be kind of compressed. I've already pre-run a lot of the commands, but just to give you an idea of this DAO starter kit that we have that you can take advantage of if you want to experiment with making DAOs on FEVM. So quick introduction, if you're not familiar, the FVM project delivers on-chain programmability on the Filecoin network. So the FVM is the Filecoin virtual machine. And specifically, we have the Ethereum virtual machine virtualized on top of the FVM, and that is the FEVM, right? So that allows us to take advantage of all of the Ethereum virtual machine things we may be used to. So the FVM itself is based in WebAssembly. It's built to support multiple runtimes, but again, we're going to be using the FEVM, so the Ethereum virtual machine on Filecoin, right? So you can use Solidity, Viper, anything that compiles to EVM code and run it on the Filecoin blockchain, right? And so one of the big deals with this is you can actually propose storage deals with smart contracts. Now, remember earlier I said Filecoin is a blockchain that was tailor-made to store data, store the internet's data, right, and archive it. And traditionally, we would have to go through, a bunch of different APIs to get data stored on Filecoin, right? But now with the FEVM, we want to be able to get data stored and use the magic of smart contracts and code that lives on the EVM on Filecoin to create these storage deals, right? And so you can see the fib here. This was created a while back to create a deal client via a smart contract. So essentially a smart contract that emits an event and creates a storage deal. Talk a little bit about that in a bit. But the underlying infrastructure for this is this library called filecoin.sol, created by our friends at Zondax. Excellent team. And so essentially what filecoin.sol is it's an interface between the smart contract EVM world of Filecoin and the traditional APIs that we would use to make deals on Filecoin before the FVM was a thing, right? So if we go here, we can look. This is still a beta software. So there's a bunch of assumptions in here. But if we go into contracts, we can see these API contracts. A really interesting one to use is the market API. This basically gives you all the APIs to read what's going on in the Filecoin market for storage deals, right? So you can put in a specific deal ID and get the deal commitment, which is the PC ID for that deal. We can get the client of that deal, which is the address of whoever or whatever is requesting that deal. And so this is really the underlying contracts, the underlying everything we're about to go talk about going forward. And so, yeah, we're talking about storage deals. Let's kind of make it real to see it. We're going to go to Filefox. I already have a Filefox tab open here. I'm going to make sure we're on hyperspace. Do note that soon hyperspace will be deprecated and we will be doing everything on calibration net. But for the time being, everything's on hyperspace. So I'm doing this demo here. But if we go to blockchain, we will see a tab up here and it'll say deal list. I'm going to click on that. And
Zach, can you just zoom in a little bit on the screen and just make that a bit bigger?
Sure. Is that better?
Yeah. Yeah, that's good. Thanks.
A little bit
yep.
bigger.
Brilliant.
Awesome. Yeah. So we have the deal IDs here and the deals that are stored on the Filecoin blockchain, right? So I'll click on deal ID 1652, and that'll pull up that information, right? So this is reading that API in the background and getting all that data. And so this is what Filecoin.sol is actually reading from when we read from the market API, right? Like if I typed in deal ID 1652 and I went and called that get deal data commitment method, I would pull in this PC ID in bytes form into my smart contract, right? So these are kind of Filecoin deals on testnets like hyperspace. A lot of things like collateral and payments are set to 0. Deals are a bit smaller to just help you devs and actually just test out your workflows on these testnets, right? But on mainnet, these deals do require collateral. They require payments be set up for the providers, right? So you've heard me say PCID. Just quick summary, if you're not familiar with it, a PCID is basically, it's like a hash. It's not exactly a hash. It's more complex than that, but it's essentially a hash at the top of what we call an IPLD DAG that represents the data, right? So every piece of data will have a unique PCID for it. I'm not going to go into too much detail here since we want to get to the good stuff. Again, so traditionally deals were made at a API level. The process was quite long and required a lot of steps on the person trying to make the deal. And so when you're building your DAO and if you want to automate making a deal, you have kind of two main design patterns you can use. One is a bounty hunter design pattern, which just allows people to crowdfund money into a smart contract and request a bounty hunter make a deal. And if they make that deal, it'll read it from the market API and pay out whoever actually made the deal that's been requested via the smart contract automatically, right? This is not the one we're going to be using today, though. We're going to be using the client contract, right? So this is that contract I mentioned earlier in the presentation, and this allows you to emit an event for a specific deal with all of the deal information and say where that data you want to be stored is, where like a storage provider can retrieve it, and storage providers will pick it up, and as long as everything matches, they'll automatically store that deal. So that's kind of the TLDR on deal making. There's a lot of good videos in previous talks in this hackathon if you want to learn a little bit more detail about that. But now we're going to go into what are DAOs and what are DataDAOs specifically, right? And so a DAO is a decentralized autonomous organization, right? Big words, but it just think of it as adding governance to your smart contract, right? So I live in a condo, and for anything to get done in my condo, all of us homeowners have to vote on proposals. And I mean, these proposals range from something as small as allowing specific decorations on our doors, right? And of course, everyone, rolls your eyes, when you hear about these HOA processes, like, oh man, I don't want to have to deal with all of that in my own home. But when you're living in a building with a bunch of other people, there's a lot of different concerns that come from different homeowners. It's important that we represent those concerns, right? And smart contracts, a lot of them, we want them to be owned by the community. There's some processes in smart contracts that just can't be automated and require human touch. And if we want to keep these smart contracts as decentralized as possible, we should allow the community that has a vested interest in that protocol to vote on what they want to do with that protocol, how they want to upgrade it, what functions they may want to run at a specific time, right? And so that's kind of what a DAO is. It's a bunch of contracts that overlay on another contract to allow for voting and things like that. I kind of have this here facetiously, but what is data? Data is a collection of discrete values that convey information. I'm not going to go into the whole, I think you all know what data is, right? So we're just combining data with DAOs. And really what we mean by this when we're talking about it is DAOs storing data on Filecoin, right? So Filecoin, again, is a blockchain tailor-made to store data. So why not make DAOs around that use case? But, it's really still the early days of this. Data DAOs haven't been completely fleshed out. There's a bunch of different ideas floating around, but we haven't seen any huge ones. So you still have the opportunity to define what a data DAO is, and to be a part of shaping this new technology going forward. Right. All right. So I'm going to go ahead and jump into a quick demo to show some of the code for this. So a couple of resources. One is the Open Zeppelin governance contracts and their docs around this. So the governance tools I'm going to be showing actually use these Open Zeppelin contracts. When possible, I always suggest using Open Zeppelin. They're audited, very professional team. And these are kind of use all of the best practices as Solidity devs. And, why reinvent the wheel, right? And so, you can just kind of type in, if you want to find this, governance, Open Zeppelin, and it'll be here as some of the first options for you, right? And this just kind of gives you an explanation on all of the smart contracts we're going to use. We're going to set up a token contract, ERC20 votes, to give voting rights out to the community members. We'll have a governor contract that actually kind of manages the votes, and we'll have a time lock contract that puts a delay in after votes have passed to allow community members to exit for if there's like a large minority that doesn't agree with the votes. A great tutorial I suggest if you really want to learn this more in depth is Patrick Collins has a great DAO tutorial on YouTube. I actually used it to help me make this DAO kit that we're going to go through in a bit. Really excellent tutorial. He goes into depth, codes it from the ground up. Takes a lot more time than I have today, so I highly suggest you give it a look-see. If you just type in Patrick Collins DAO, on YouTube, it'll come up, and he'll walk through how to build these open Zeppelin contracts, right? And finally, we have this DAO app kit kind of built on that architecture. But here in our contracts, we're going to have the deal client, right, that I talked about earlier. This is the contract that will emit that event that storage providers can pick up and use to store data, right? And so you can find this in Filecoin project FVM DataDAO kit. Scroll down. This is a beta kit, so it's still being built. There's going to be a lot more functionality I think we foresee for DataDAOs, a lot more tools being built on top of that. But for right now, we have the basics, open Zeppelin contracts, wrapping the data client contract, right? And we have all the instructions we need, how to clone it, and all that good stuff. So I'm actually going to switch now to my VS Code. All right, can we see that, Matt? Is the VS Code popping up? You there, Matt?
Yeah, sorry, I had myself muted. Yes, we can see your VS Code. It's come up.
Sweet.
Thanks.
Awesome. Yeah. Let me know. Let me know if the text is small. I know these can get kind of small. I have an ultra wide, so that's why the text always gets a little weird on here. But yeah, so here, I've already cloned this kit into my file folders, and I've kind of already opened this to save us some time. I've pre-ran a bunch of commands. I'll tell you what commands I've run. But a lot of these take time. There's again delays built into a lot of this, so that's why I've gone ahead and kind of prepared this already. But yeah, after you clone it and you open it, the first thing you want to do, of course, is run yarn in the terminal. Oh, it's too big. Yep. So you're going to want to run yarn in the terminal. This will download all your packages. And then you'll run yarn hardhat deploy, right? And this will run our deploy scripts. In this case, I'll run through them real quick. Our deploy scripts are a little bit more complex than just straight deploying them, right? They do a lot of setup, right? So if we look here at our first deploy script, you'll see that here, we call it, we deploy this data governance token. And I'll increase this a little bit. And we actually call the delegate function, right? So we're not just deploying it; we're deploying it and delegating the a token to our the wallet that's actually making the deploying, right? So again, we have these ERC20 votes contracts, right? If I look through the contracts here, you'll see we have the DAO deal client, we have the data governance token, which is the token that we've set up. My Siri wants to go off for some reason. We have our data governance token. This is used to delegate out voting rights to community members. You have the governor contract, which actually takes in the votes, and this is really kind of the brains of the governance process. And you have the time lock, which provides that buffer again in between the governor and the logic, which is the DataDAO deal client, right? So whenever the governor, you make a proposal, a bunch of people vote on that proposal. When it passes, and it's going to call a function on the DAO deal client, we'll have the time lock in the middle kind of intercept that and create a delay. That way, if people say, hey, I see this vote coming in, it's going to execute. I don't agree with it. I don't want to be a part of this. They can exit the ecosystem, right? And so when we're actually sending these deployments, we're deploying the token contract, we're delegating some tokens to ourselves so we can vote. We're deploying the time lock contract and setting its initial parameters, right? Its constructor. We deploy the governor contract. We set up roles in our contracts here. In the time lock, all of these roles need to be set. And finally, we deploy the DAO deal client contract, and we set the owner as the time lock contract, right? So this way, the contract goes and it's out of our control immediately. The DAO has control of the contract and no one else, which is very important for decentralization, right? And so when you're on a hard hat deploy, you're on hard hat deploy. It's going to go through each of those contracts in the order that they're listed. And if I scroll up here, you can see it going. See, it'll compile everything. It'll deploy the data governance token. It'll delegate it, deploy the time lock, and it's going to run through each of those commands, right? This takes some time. There's a lot of different methods that need to be run. But yeah, once you do that and you have everything deployed, you can actually run the scripts for the DAO, right? So we have 3 scripts here: propose, vote, and queue and execute, right? So propose, we'll call the propose function on our governance contract and just propose a data deal, a deal proposal. Sorry. So basically, a proposal for data we want stored on the Filecoin network. And if we actually look in our helper hard hat config, you'll see here we have hard coded the deal proposal that we want to propose. A lot of proposed terms being thrown around here. But essentially, this is the data we're saying, hey, I have this PCID somewhere. The data is this size. I want the data to be stored on this block. The deal ends on this block. And, you can find the actual data to retrieve it here. And some other deal parameters, right? So that's actually what's being read and proposed, right? And so you can see here, to do that, to run this script, you would run yarn hard hat scripts you'd run yarn hard hat run scripts / propose.js, right? And that'll run it. I've already run this function. So after you run that, you'll see here, this is me running the command, and it's proposing make deal proposal on the contract, all that data that was in the helper hard hat config. And again, this proposal is to store that picture, that attack cat picture I had at the beginning, right? So, we have a little description, store attack cat, and it went through, gives you the proposal ID, and tells you, hey, the state of that proposal is currently 0, which means it's just proposed, not voted on. And so the next thing you'll want to do is, open up a period. This will open up a period for that proposal to be voted on. So, if you have a token, one token, in this scenario, there's one token, one vote. This is kind of where it's up to you to design your DAO, how you want it to be. This is one of the most simple ways to implement a DAO. And remember, we delegated tokens to ourselves at the beginning, which allows us to vote when we deployed the contracts, right? And so this contract automatically votes for that proposal, right? And so again, you'd run yarn hard hat run scripts / propose.js, and that would run the command. to vote right here, right? And you say voting, let's get the cat stored. And it goes through and it moves the current proposal state to 1, which means, hey, it's voted on, it's ready to go. And the last script you would need to run to execute that vote is queue and execute. So yarn hard hat run scripts / queue and execute.js, and I'll actually run this one. And so then that will go through. Hopefully it goes through. And too much time may have elapsed since we voted on it. Yeah, so that is kind of the DataDAO kit in a nutshell. Definitely going to be a lot of development on top of this. I'm going to go ahead and go back to my presentation to end this up. All right, so yeah, that was a quick overview of the DataDAO kit. Again, some resources. If you want to be able to find this, you can find it at on our GitHub. Here's a QR code and a link. Also links to our Foundry starter kit. This was actually started by a community member. I always want to shout him out, Xinghan. Thank you for making this. And we've kind of taken it over. So this has a bunch of starter contracts and starter scripts to get you started on with developing on the FEVM using Foundry. We have the Hard Hat starter kit, which is the same thing, but for developing with Hard Hat, if that's what you so choose. The deal making app kit, right? So if you want to learn a little bit more about just specifically the deal making process that you saw with that deal making contract, please check out this kit. There's actually a big PR in that should be merged very soon to refactor the whole kit and make it a little bit more easy to use. But this is kind of the go-to kit if you want to just focus on that one piece. And finally, for everything else, we have this awesome link tree with a bunch of other resources that you can check out to help you along your journey developing on the FVM. So thank you for listening. I know that was a lot, really fast. I hope you found it helpful. And again, if you want a little bit more help or have questions, feel free to reach out. Check out all those resources I pointed to earlier. And happy hacking.
Fantastic. Thanks a lot, Zach. That was great. I don't know if people have any questions. We're kind of running just a little over time because we gave some time at the start just to wait for people to come in. But if people have any questions, if you want to put them in the chat now, we'll just spend a couple of minutes, and then we've got the next speaker queued up, ready to go. So we've got the next talk is with Mitrasish from Spheron, who'll be coming on in just a moment. Hi, Mitrasish. I'll bring you on in just a second. I just want to see if we've got any questions for Zach on here. Someone's asking about whether they can get access to your slides. And yes, I'm sure we'll make them available via Discord in there as well. We'll put them in the Discord, the IPFS Discord. So that's where most of like the help and support is happening kind of throughout the hackathon in the IPFS Discord.
Sure.
Great.
I'll try to add it to that repo as well, the README.
Yeah. Okay. Yeah, that'll be cool. Right. Okay. So I don't think we've got any more questions here. If anybody has any more questions, yeah, as Carlin Papillion says in the chat, you can put them in the Discord chat as well. So brilliant. Thanks very much, Zach, and great. And we're going to now move on.
Thank you so much.
Yeah, no problem. We'll move on to the next talk. So now we've got Mitrasish.